Will technology save humanity? Nanobots are being created to carry out tasks, particularly in medicine, to destroy diseases, administer drugs, and improve vaccines. We're seeing this play out presently in today's day and age. Yet nanobots can be a serious problem. First, they require many hazardous materials and UV light in order to function, and even lose control of their targeting systems and go haywire. Biowarfare is said to be used for infecting, incapacitating, or killing either plants, animals, or even humans, specifically during conflict. This can lead to serious outbreaks and even erode genetic diversity within natural environments and populations, and endanger even more species. Luckily, after World War I, the international community banned chemical and biological weaponry, and it has been strictly reinforced after the early 70s and 90s, mainly due to these reasons. With biotechnology, we have made improvements of using less carbon emissions, reducing toxicity as scientists continue to push for reaching their goal of zero emissions. Within the next 20 years, biotechnology will improve tenfold, and we will see amazing advancements in this field. This form of technology can possibly integrate itself into the genetic code of organisms, and possibly make new viruses and diseases, as transgenic DNA is a great danger to ourselves. Take the COVID-19 pandemic, for example. It is thought that it originated from natural causes, but it also raises the uncertainty of what can be released from a lab on accident. Self-replicating robots are useful for creating resources in areas that are impossible for humans to traverse. Yet it takes the use of raw materials in order to replicate from an environment. This could deplete more of our planet's resources and overpopulate as well. Nuclear war is something that most people wouldn't ever have to worry about, but it is still a possibility. There are about 12,700 nuclear weapons on the planet. If one were to detonate and cause a chain reaction, millions would perish within minutes. Climate destruction would further commence with a nuclear winter, and global famine and radiation would kill just about anyone lucky enough to survive the first couple of hours. An asteroid impact is believed by scientists to occur once every 50 million years or so. The last one is believed to have impacted about 65 million years ago. Does this mean we are 15 million years past due for another planet killer? Scientific data says that there are almost 5,000 to 15,000 potential hazardous asteroids orbiting our sun, all with a diameter of 100 meters. The last supervolcano eruption happened about 27,000 years ago, and it is believed that one occurs every 17,000 years, indicating that we are 10,000 years past due for another eruption. But the odds of a nuclear war, asteroid impact, and supervolcano eruption are very small. The biggest risks to humanity are wildlife extinctions, climate change, pollution, overpopulation, resource depletion, ecological collapse, deforestation, and artificial intelligence. It has been predicted by Stephen Hawking that by 2600 our entire planet will be engulfed in flames. By then, it will be entirely uninhabitable due to mass energy consumption. So how can we survive? Mars is thought to be the best place to recolonize humans. It has water, a good temperature, and atmosphere to protect against some ultraviolet rays, and the gravity there isn't too bad. Robot mining is the first step for humans to colonize the planet. Once water and fuel are properly gathered, by 2050 humans will be able to start colonizing. Europa, Titan, and Enceladus are also thought to be capable of supporting life, yet life would have to exist in subsurface environments. Our moon is another good option, but it has an unbreathable exosphere and would be only convenient for setting up moon bases. Setting up interstellar spaceports and moon bases will all be major contributors to the harvesting of material in our solar system's asteroid belts, moons, and even planets. The closest habitable planet to our solar system allegedly is Proxima Centauri b. Colonizing on any other planet, moon, or spacecraft is extremely difficult. Weather conditions, factors of the atmosphere, distance from our planet, and the amounts of resources required to support human life all determine whether humans can survive. There are many obstacles to overcome before we can start sending people into outer space. Construction in space is a lot harder than it is on Earth. We lose the protection of our atmosphere from solar winds and radiation. Creating a new one is way more difficult than fixing the one we already have that is in extreme crisis. So many advancements like artificial gravity and nuclear fusion are far out of reach. Things like nuclear fusion are extremely difficult to master. One nuclear fusion power plant would require 10 electric shocks per second, and scientists have just barely figured out how to produce only one. Plants would require 100 times more energy. One fusion plant would require 300 grams of tritium a day in order to generate 800 megawatts of power. One diamond shell is used per test, and one power plant would require 900,000 of these shells a day. We would need much more efficient lasers as well. Many believe we will not have one even after 2050, yet some believe one could be made within the next 20 years. It probably will not arrive in time to help solve the climate change disaster though. One plant would eat through the whole global supply of tritium within 2 months, and 800 megawatts of power is only enough to power about 2% of France. They also require 216 to 560 tons of beryllium, with the annual global supply at about 216 tons. It seems like we would only be able to create only one nuclear fusion power plant, which is very costly and extremely hard to dispose of. Fusion propulsion can be up to 100 times more fuel efficient than chemical propulsion, while still maintaining large thrusts, making it a prime option for transporting large payloads to distant destinations or ferry going to and from the moon. Megastructures like Dyson spheres are far from the scope of what our technology holds today. It is predicted that they could be built within the next 100 years. It would take half of Mercury's materials. Mercury is close to the sun and has plenty of iron, some of Venus, some of the outer planets and asteroids, just to build one Dyson sphere around our sun. Over the course of 50 years, swarm robots would be used in order to multiply more and more in order to create the necessary building equipment like satellites and panels. It is estimated to take around a decade to extract, process, and position all these materials. 10 years should be the amount of time it takes to construct each array, and the energy gathered from this first swarm is used to construct the rest, which would speed up the process. A Dyson sphere might be the size of Earth's orbit around the sun. It would have to be made of materials way stronger than anything that already exists on Earth in order to survive asteroid impacts, comets, and solar flares. We would have access to 3.8 times 10 to the 26 watts of energy. The sun emits roughly 400 septillion watts per second of energy, which is about 1,000,000,000,000 times our current worldwide energy use. We could construct megascale supercomputing, mass drivers, ancestor simulations, virtual universes within universes, terraform other planets, form space colonies, or building other megastructures such as a stellar engine to move our star in the solar system through the galaxy, all while maintaining the Dyson sphere. With the rise of artificial intelligence and the replication of cells, self-replicating robots is far from impossible. We are already experts at 3D printing, and we are building robots, and we have recently been able to reconstruct cell-like structures. Given the progressively worsening condition of Earth and our ever-growing demand for living space and resources, we have no other choice but to rely on constructing a Dyson sphere in order to survive. The only real alternative we have is solar energy and something called carbon capture. Solar energy has already been used to power spaceships on Mars and is likely to grow more and more throughout the future. Carbon capture is the process of capturing carbon from industrial processors and converting it into baking soda and transporting it into the ocean. So what does all this mean? With the rise of technology, medical health problems likely will not be an issue in the future if accidental outbreaks do not occur. The same goes for biological warfare. Self-replicating robots may pose a risk to our supply of resources, but are extremely vital to the development of technology, especially the Dyson sphere. Things like a nuclear war, asteroid impact, and supervolcano explosion are likely not to pose a serious risk in the future. But with the rise of climate change, wildlife extinction, resource depletion, overpopulation, pollution, deforestation, and ecological collapse, humanity may face extreme droughts, typhoons, wildfires, collapse of ecosystems and agriculture, mass migrations, famine, and conflict. By then, humanity will have to recolonize on a global scale. Hopefully scientists are correct and we may master nuclear fusion and can use a nuclear fusion reactor's energy in order to get us to great distances around our solar system. Since making just one nuclear fusion reactor is so costly and excruciatingly difficult, I think if scientists can just pull off even one, they should save it for space colonization and to honestly ditch trying to stop climate change with it, because honestly there's no stopping what humanity has already done to the planet at this point. Once we start colonizing colonizing Mars, setting up moon bases, spaceports, and start harvesting resources from other planets, asteroids, and moons. With the help of self-replicating artificial intelligence, we can start constructing the Dyson Sphere. By then, our entire solar system will be changed forever. We may still be able to learn about our astrology signs and how each characteristic from each planet influences our characteristics, but the true forms of our planets will never be the same as they once were. Although it will be a breakthrough for humanity, I personally find it kind of sad that we will have to eventually destroy some of our own planets in order to survive, and they will lose their original beauty due to our own harvesting. But once we harness the entire energy of the sun, the planets of our own solar system will no longer be the only companions we have to keep us company, because we will be able to travel to not only to Proxima Centauri b, but basically anywhere in the known universe. You usually hear of harvesting planets for resources in sci-fi theories about aliens invading us and wiping out our own race for resources. But honestly, due to the fact that our planet was formed in the habitable zone, the moon didn't destroy us and helped us sustain life, and just the mere fact that we are an advanced civilization of our own, it kind of seems like our solar system might have been set up as some sort of experiment in order to see if we will be able to evolve on Earth, make use of all the material around us, and use the material to finally harvest the heart of our solar system. Or maybe that's how all civilizations are. They evolve on their home planet, evolve once they run out of their resources on their planet, they learn to harvest the resources around their parent star until they are able to harvest the star itself, and eventually branch off to other solar systems and let the cycle of evolution continue. Some believe Mars once had an ancient civilization on it, and the radiation on the planet is due to other civilizations fighting over control of the civilization on Mars and eventually nuking it entirely. Makes me think how many advanced civilizations before us have existed on Earth and are buried under millions of years of erosion beneath the Earth's crust, and how they might have gone extinct, and how many advanced civilizations have ever existed on other planets within our own solar system, or even are orbiting around our solar system and possibly harvesting energy from our asteroids, planets, and sun. If they are, hopefully they will leave enough for us to consume. Or who knows, maybe they'll finally invade our planet and harvest all our resources and just put an end to all our suffering. But I'm sure that's not likely the case because they probably would have already done that by now at this point.